Hello friends, I'm back, and I'm back to show you how I do this. And you can see there's the other sketch kind of coming through with these crazy circle balls. But what we want to do is take this page and make it sing. And that page is this page here. We're not going to update this circle, so we can take that out. I'm going to bring this background back, because I like the background. And what we need to do is, well, first of all, we're going to need to map over these circles, right? So we're going to say circles dot for each circle, we're going to draw a circle, right? So that's where that's going to go. And we're going to get rid of this and make that circles. Now, we do need to take this update circle function and basically put it in this create circle, because what we're going to do is, what we want to do is make that pattern be static. We can also make it be moving, which we can do next. But first, let's just take this I value in. So this index value is going to be a number between 0 and 255. And we can pass that in. And I'm just going to pass it in as IDX to make sure that I keep my brain straight. And I'm going to actually make this color be a gray color. So now we'll get a grayscale color essentially, and we could also just make this be IDX like that, and that would give us that same grayscale color. I'm going to make this smaller, and I'm going to make X be just I dx for now. And then for this Y value, we're going to take this function right here, or formula right here, this formula with a function, and what we need to get is this angle. So this angle is going to be, if we take a look at this angle is, what we want to do is go from here to here. And if we want to go double like this, we'll have to make this length be doubled. But what we want to do is we want to have 255 points making a complete rotation, which would be 2 pi. So we know 2 pi is going to be in there. And so we know we're going to have this 2 pi. And what we're going to do is have 255 divided by 2 pi. So that's going to be basically divvying up each one of these 250, divvying up 2 pi into 255 different chunks, if that makes sense. And we'll just divide I over that. And we should get the right thing. Let's see what we get. Oopsie daisy, I got an error. What did I do wrong? Let's see. Check our console. I is not defined at create circle. Right, exactly. This should be IDX. And there we go. So now we get, I did it with the 255 times 2, so we get 2 complete revolutions. And there it is. 1, 2. Oh, interestingly, I had the grayscale run for the entire index. So that's interesting. So we could do, if we do 1, right, we just get that. Now, if we want this to go back to, if we want it to not be just white the rest of the way, what we could do is we could go index modulo 255, right? And so now we go back to that hard black, and we repeat. Now, if we want to make these into a circle, which might be kind of fun, what we could do is also get this X. Remember, I had said before we could say cos of that angle times wave height plus canvas height, no, width over 2, so that should go in the center. And there we go. So now we get that circle. I don't know if any of this is making sense to you. It's kind of making sense to me, but I've been doing it for a while. What I've just been trying to demonstrate is how these basic trigonometric functions can help us create oscillating motion and also motion, circular motion. And we've been kind of dabbling on the edge of this sort of Cartesian to polar coordinate conversion. I'm not going to go deeply into it here, although I'm happy to talk more about it with people if they bring it up with me. What I want to do next is really think about how this turns into a pendulum. And I think it's easy to see how that might happen, right? We're going to need to have a line, and we're going to need to have this angular motion, but we're going to limit it so that it can't go all the way around. And I'm going to show you how to do that in the next video. All right? So I'll see you there.